Okay, after we find the foot of perpendicular from a point to a line, this new section talk about the foot of perpendicular from a point to a plane. So again, one numerical example to run you through the theory behind it. Okay, same thing, you have a point P given to you, and then you have the equation of the plane given to you. You need to find the foot of perpendicular from point P to the plane. So diagrammatically, this is what's happening. This is point P, this is the foot that we are interested in. Okay, to find a foot of perpendicular from a point down to a plane. So the first method that we have is the intersection of the line and plane method. So you need to understand, okay, this is point P, this is point F. So can you actually write down the equation of the line PF? So right now you must understand, to write down the equation of a line, I need a point, I need a direction. And the equation of the line PF will be R equals to A plus lambda B. So this A must be OP, okay, a point on the line, which I use OP. And where is the direction of the line? The direction of the line is exactly the same as the normal vector of the plane. Okay, I say again, because F is the foot of perpendicular, PF must be perpendicular to the plane pi. So PF is parallel to the direction vector, to the normal vector of the plane pi. And so the direction vector of the line PF must be the same as the normal vector of the plane 2, 0, 1. So what I have now is the equation of the line PF. You also have the equation of the line of the plane in R/n form. So look at it diagrammatically now. Point F happens to be the intersection between your line PF and the plane pi. So your chapter 5 concept must come in. I am going to find the intersection of my line PF with the plane pi. So how do I find the intersection of this line with the plane? I'm going to equate these two equations together. So putting equation 1 into equation 2, I solve for S to be 0.8. So when S is equal to 0.8, I put back into your first equation. I will actually get OF to be this. And this is actually the intersection of the line PF with the plane, which also is the coordinate of the foot of perpendicular and the coordinate of your point F. Okay, so that is your first method to find the foot of perpendicular. The second method is that I am going to activate your projection again. Projection skill comes from vectors 2. So diagrammatically, this is what we have. Okay, point P, point F as the foot of perpendicular, but this time around I'm going to create a triangle. I'm going to find a point A. So I'm going to randomly call a point A as anything that can satisfy the equation of the plane. Okay, this is the equation of the plane. Anything that can satisfy this equation will be a point on the plane. So to make it as simple as possible with as many zeros as possible, can I say that 2, 0, 0? Okay, can I say that 2, 0, 0 is a point on the plane? Because 2, 0, 0 dot with 2, 0, 1 gives me 4. It satisfies the equation of the plane. So I'm going to say that, okay, a point A, I'm going to call point A 2, 0, 0. So now look at what you have. I have point A, I have point P. Can I find AP? What else do I have? I have the direction vector line. Okay, so I can actually find PA. Okay, I go and find PA. PA is 2 minus 4, 0. Then PA dot with n hat. PA dot with n hat, normal vector, will actually multiply by n hat, will actually give me PF. Okay, PA, focus on this triangle. PF is actually the projection of PA onto the normal vector of the plane. So PF actually is PA dot n hat multiply by n hat, fit everything in, you have your PF. And with that, I can find what is OF. Can? Okay, then of course after that, the extension will always be finding the reflection of a point in a plane. So diagrammatically, if this point P, the reflection of the point P in your plane will be P prime. So it is the same theory as what we have. This is equidistance. To find the reflection, activate ratio theorem because they are equidistant apart. So same thing, this is just an extension from your example 8. Assuming you have already found what is OF, to find your reflected point, activate ratio theorem from your vectors 1, you can get your reflected point in the plane.